In this video, we'll be talking about catalysis. The first question asks us, in what 4 ways does a catalyst work to create a more favorable pathway for a reaction? The first 2 most obvious ways are going to be increasing the reactivity of an electrophile or the nucleophile, depending on the reaction. A catalyst could also make a better leaving group, or, for the last way, it could increase the stability of the transition state. For the next question, it asks us to draw both specific and general base catalyzed dehydration of 2,2-propanediol and to specify what the difference is. So our structure that we will be looking at is this, and if we were to do specific, that means we would do a 2-step reaction. And the first step would be to deprotonate one of the hydroxy groups. And then we would perform the dehydration part. Now, if we are to do general, that would mean this is a 1-step process where we would remove the proton and dehydrate in 1 step. Now we are asked to determine what the difference is. So for these 2 reactions, we get the same exact product. However, we can see that with specific, we get 2 steps. We get a fast and then a slow step. And then for general, we get 1 slow step. This is going to be very reaction specific, and depending on the reaction, it could favor specific or general. For the last question, we have to determine what type of catalysis is occurring. This is the slow step, and if we are to compare the 2, we can see that this part of the molecule broke off here, and that oxygen became protonated. We can see this hydroxy group became deprotonated. And we can see that we protonated one of these hydroxy groups. Since we have one slow step, this is going to be most likely general. Since we're not adding a catalyst, we only have our molecule here. This is going to be intramolecular. Now we need to determine if it is acid or base catalysis. Now for the mechanism, this bond is going to break, and this is going to become deprotonated here. So this is going to pick up the hydrogen, and then this is going to form a double bond, but still retain that proton. Therefore, this will be an intramolecular, general, acid-catalyzed mechanism. That concludes the video on catalysis.